Ah, it is so nice to be back by the shore after all that time out at sea. Hey, Mia, check out those signs on the ground. They look like a number line. I bet there are some times like high tide when the water goes farther up the beach, and other times like low tide when it doesn't go as far. Good question. How would we compare those measurements? Well, it all comes down to rational numbers and inequalities. In this lesson, we'll work with both inequalities and rational numbers to compare different values. By the end of this lesson, you'll be able to use inequalities to compare positive and negative rational numbers. Let's get into it. Let's start with a quick refresher. We recently learned about rational numbers, which are positive and negative numbers that can be written as a fraction using integers. That includes mixed numbers, decimals, and integers themselves. But we're also using inequalities today. Do you remember the symbols we use to compare values that aren't equal? That's right, less than and greater than. So back to the ocean. At 10:30 this morning, the water was generally coming out to about 1.75 feet, according to the signs. By noon, it reached 2.5 feet. At what time did the water reach farther up the beach? Let's figure this out. Feel free to use the number line in your guided notes as a tool that can help you find your answer, check your work, or in any other way you find helpful. This time, I'll start by plotting both values. Go ahead and pause the video if you'd like to plot them on your own first. $1.75 will go here, between 1 and 2, but closer to 2. Meanwhile, 2.5 will go here, exactly in the middle between 2 and 3. On any horizontal number line, the farther you go to the right, the bigger the numbers get. So because 2.5 is farther to the right, it's the bigger or greater number. Written as an inequality, we would say that 1.75 is less than 2.5. That means that the water reached farther up the beach at noon. But what if we have measurements written in different forms? In this next example, the water reached 3/2 feet at 9 p.m., and it reached 1.2 feet at 9:30 p.m. What would you do to be able to compare them? Exactly, you could convert 3/2 to a decimal. Pause the video and write an inequality to compare the two values. Three halves as a decimal would be 1.5, which is greater than 1.2. That means the water reached farther up the beach at 9 p.m. We can confirm this by seeing that 3/2 is plotted to the right of 1.2. Nice. What about negative values? The water reached negative 0.8 feet at 6 a.m., according to the markers. At 7 a.m., it reached 0.6 feet. When do you think the water was farther up the beach? Whatever your answer is, let's use the number line to double check. Here are both points on the number line. I see that negative 0.8 is on the left and positive 0.6 is on the right. That means that negative 0.8 is less than 0.6, and 0.6 is greater than negative 0.8. The water reached farther up the beach at 7 a.m. Think about what we know about positives and negatives on the number line. Do you think a negative value will ever be greater than a positive value? Yeah, because all positive values are to the right of 0 on the number line, and all negative values are to the left of 0, any positive number will always be greater than a negative number. Here's another pair of numbers, -3 and -1. If these numbers were positive, we know pretty quickly that 3 is greater than 1, but how do they compare to each other when they're both negative? Let's use the number line to figure it out. Now we can see that -3 is farther to the left, and -1 is farther to the right. So which value is greater? That's right, -1 is greater than -3. So our inequality would look like this. That might seem backward, but it all comes back to the idea that the farther to the right a number is on the number line, the greater the value. Since we count to the left on the negative side of the number line, a negative number that is farther away from 0 is considered more negative and will be less than a negative number that is closer to 0. Let's make sure we're getting the hang of comparing only negative numbers. Give this one a try. Compare -2.25 and -2.75 using an inequality symbol. There's a number line in your guided notes that you can use if you find it helpful. Pause the video while you work. Both values are between -2 and -3. But -2.25 is closer to -2, and -2.75 is closer to -3. -2.25 is on the right side, so it's the larger value. The inequality will be -2.25 is greater than -2.75. Here's the final example. Can you compare a negative fraction to a negative decimal? Give it a try. Complete the inequality to compare the values -5/4 and -2.5. Go ahead and pause while you work. First, it might help if we convert -5/4 to a decimal. That would give us -1.25. Now that both values are in their equivalent decimal form, we can compare them from here or put them on the number line to see that -5/4 is farther to the right, making it the greater number. Our completed inequality will say -5/4 is greater than -2.5. Nice work. Great job, everyone. Now you know how to compare positive and negative rational numbers using inequalities. Ooh, yeah, building some sandcastles sounds like fun. Let's do it while the water isn't coming too far onto the beach so they don't get washed away. Don't forget to complete all the practice activities before our next lesson. See you next time.